What's going on, guys? Bruce from Jump Mathematics. In this video, we are going to be talking about a linear approximation. What is a linear approximation, you ask? Well, what we're going to do is we're going to, given any function that's differentiable, we're going to be able to draw a line through a particular point such that the value of the line corresponds to the value of the function and the slope of the line is the same as the slope of the function at that particular point. This is really good because sometimes functions can be really difficult to evaluate. So a linear approximation, since lines are easy to compute, a linear approximation gives us a pretty good estimation for a very small area near our point x0. So let's talk about what the linear approximation needs to satisfy. One, it needs to match at x0. The y value needs to match at x0, and two, the slope needs to match at x0. So first let's calculate what is the y value of this point. X0 was just the arbitrary point that we picked to say our linear approximation centered at x0. So the y value is just going to be, you plug in x0 into f and you get f of x0. Okay? The slope needs to match at x0. What is the slope of f of x at x0? It's of course f prime of x0. Okay, so now we have a point. Our point is going to be x0 comma f of x0. And we have a slope. What can we do with a point and a slope in order to find? We can use point slope formula. Y minus y1 equals m times x minus x1. Okay, our y1 value, this is the y value that we know, and we know that to be f of x0. M is f prime of x0, and then times x minus x1 is the point that we know to be x0. Now let's go ahead and we can add f of x0 to both sides. We get y equals f prime of x0, x minus x0, plus f of x0. Okay, now what we often do is rename y, we just call it L of x for our linear approximation. So we see that the linear approximation of x centered at x0, that means we pick a particular point at which the line and the function intersect and that the line and the function have the same slope, equals f prime of x0, that's our slope, x minus x0, that's how far away we've deviated from our center point x0, plus f of x0, that's basically where we start, and then we go up or down on the line. In the next video, we're going to see how we can apply this linear approximation formula in order to approximate some tricky function values. See you there. Hey, what's going on, guys? Thank you for watching the video. If you're interested in getting better at math by getting all kinds of practice, what I want you to do is go to jumpmathematics.com. Here I provide you with free instructional videos and hundreds of practice problems. This is the best way to get better at math by doing practice problems. See you in the next video.